Okay, so I have a couple things to show you this Thanksgiving week. So let's get started. Try to keep it brief and concise. It's just good things good to know. And I want to start with this resampling of DEM data. Because we use, the tools that we've been using in class are the streams extract. And I know a lot of people had trouble with that, but here's the thing. I'm going to show you. This is a high resolution DEM I downloaded from the West Virginia GIS Tech Center, and it is a 1 meter by 1 meter pixel size. Well, what that means is that it's 1 meter times 1 meter, so that's square meters. And in this case, we usually, and I have in the past, we've used a DEM that was 30 meters. So that's even bigger. It's even a bigger raster size. And you can see that when you zoom in. It's going to zoom into show it on the pixel level. You can see those pixels. Here's the 30 meter. So it's substantially bigger. 30 by 30 meters is actually, it's 30 times 30. So this, 1 square in the 30 meter DEM is 900 square meters. And so it's not real high resolution like this nice 1 meter DEM here. But what I ended up doing was I wanted to test out speed of the tools and how they affected the results. And in the resample, I just started dividing it in half. So I resampled it starting at 30 because, in our example, we used a national 30 meter DEM. So I resampled this Cabell 1 meter DEM to 30 just using this simple resample tool. It's as simple as to putting the new size of the cell in there. And, and this was the results. It's the 30 meter digital elevation model. So what I did from there is halved it, 30, 15, 7.5, 3.75, and then 1.875. And this was just running the tools. It was basically just saying, stream extract, the different size ones, from 30 meter on down to the smallest one. Actually, it failed on this 1.875 one. And then the 3.75 was really slow. Now, surprisingly, the 7.5 was acceptable, and it worked well. It got results. It didn't crash. Everything looked good. And then, the 15 meter was, better. And then the 30 meter. 30 meter is really fast. But what I wanted to do was check the results, because what we use this for is to create a basin very quickly. And, if we use this 30 meter one to do the stream extract, we've done the flow accumulation at 200. It gets really fast. I usually add an extra zero for some more memory. But man, it screams. There's no waiting on it. And even creating the actual basin is really fast too. And, so these were the results: your flow direction, your points. There's a thing you have to do about measuring the area. If you want to know your accumulation's specific size, you really have to know the area of your cell, and in our case, convert it to a value that makes sense, like square miles. And that's some math, but if you want to document how big you studied the watershed at, you have to do that. But the big key is to remember that it's not 30 meters, it's 30 times 30, so the area is 900 square meters. So you're converting 900 square meters to square miles if that's the units you're using. But anyway, I wanted to know how it affected and how these different results affected the outcome, which in our case, we use the water outlet to do a watershed. So I did that. I thought, well, let's just take the biggest difference. Let's compare a 30-meter watershed to one that was made on the 7.5. So here's the one that was made on the 30-meter watershed. And you can zoom in here and, you can see those squares. Let me turn that on and off for you. So, you can see that. This one you can see really good. It goes around that. And here's the second one. You can see how much smaller it is, but look at the results. This one is 11.48 square miles. This one is 11.03. So it's not that significant. It's just not hardly worth. It's down to the hundredths. This is 0.05, and the programs we use doesn't even go that low when you're putting in the square miles for the basin. So I don't think it's a significant thing. So as far as, how accurate is what we're doing using the 30 meters, hey, it's pretty darn accurate because this is a distributed process. I mean, what happens is, cells are in and out, based on their location, and it's distributed. Any error is distributed across this whole area. So that's why it's not that significant. So just wanted to share that test with you. I've been wanting to do that for a long time just to see for myself, how accurate. You get into other issues when you start using these really high accuracy DEMs, especially because it's more particular about where you select that watershed, and you just got to be careful. But there's no reason why this 30-meter DEM is not sufficient enough for what we're using it for. But anyway, that's what I wanted to share. That's one of the things I wanted to share with you. I think that one's a pretty cool one. The other one is this REST service download that I came across recently, and I've worked in I worked on this portal with a team that developed these layers, these models for these layers for what is called the EPA Water Resource Registry, or EPA WRR. And it's actually a website where they published these state models that do specific things for environmental type restoration and preservation. And you can go in here and look at these layers. But what I wanted to show you was, I wanted to download these. And back when I was working on this team, this tool only supports like the creation of a very small project. Well, I wanted to use it for a project that was a watershed size. Here in this area, this whole Four Pole Creek watershed, and it was I forget how big it was, but it was pretty good size. And the tool did not support that size of a watershed. So they sent me an Esri tool where it allowed me to download these layers, which are right here, these suitability layers. So right here is wetland preservation, and so there's some wetlands area in here, and this is for the entire state. So what I did was I found this resource. Okay, here it is. This is the layer I want to download. I want to show it to you, and it's really pretty cool. And it even has this legend, which is nice because I want to show you how neat this using QGIS to download this resource is, and especially knowing that you really can't do this in the Esri ARC tool, and how powerful it is in the QGIS. So remember this, the suitability is on a scale of 1 to 5, 5 being the best. So if I go back to my tool, I've already been working on this, and I actually tried it on a number of things. I did notice that what goes on here is that a lot of it's based on your source, where it comes from. So it might be hit and miss on if you can use this, but when it works, it's pretty awesome. I mean, this is wetland preservation for the whole state of West Virginia. All I really did was go into the data source manager. I used the ArcGIS feature service, created a connection, connected to it. Okay, it's taking a little while. I hope it's working. Obviously, I did this earlier. Oh, come on. Let's work. There we go. So, I connected to the West Virginia one, which is down here, water resource preservation right here. And so that's what I have right here in the layers. So now I can just open that up and see all the attributes. Here's the grid codes that says suitability, from 0 to 1 or 0 to 5. And I can just save that whole layer, just export save feature as, and it would, downloads it to a local, and you use all the features from QGIS. What I tested was downloading it as a shapefile, and it worked great. I have it local. But the other thing I wanted to show you too is, a lot of times you can filter on things, and there's not a filter for this particular type of layer. Most of the times when you're using the shapefile, there is a filter selection in this context tool. But here's what you can do. You can open up your attribute table, and you can do the filtering from the attribute table. So it makes it even more powerful. So here I'm going to tell it to select everything that's grid code 5, which is, that's the best. I only want and need the best. So here we go. We're going to say, we're going to select the grid code in the field, grid code equals 5. Then I'm going to hit select features. Oh, that's a 4. Grid code 5, select features. So now they're all selected, and then if I want to test it out, I can just show the selected ones. And then if I want to actually see, that the ones I selected, I could zoom in, and the selected ones are in yellow. So now I can do export, save feature, save selected feature as, and change it to, like I said, I've only tested shapefile. You could probably do all of those, but let's just say WRR01. Bam, there it is. And we have the whole state with that particular resource. All the most highly rated wetland preservation areas in the state. And I just think that's pretty cool because it's pretty powerful. It's like, yes, there's 2 great programs that do GIS, and this one's free, and it's a great tool. So enjoy and have a good rest of the week.